Hello, welcome everyone. Welcome back to my channel. Today we are doing the paper. Well, it's a continuation of the paper. We have already done the questions till question number 16, and today we are starting from question number 17. It's paper 3, Higher Tier, June 2023. Well, before we start it, I'll say that we are running crash course for GCSEs for all the subjects at just £6 per hour. And also, if you're looking for classes for any subject from year 1 to year 13, just drop us an email at exacademy@gmail.com to book your free demo, and then we'll coordinate accordingly. If you're looking for the free worksheets, they are available on our website, which is gcseacademy.com. Well, let me start with the question number 17. It says, here is a distance time graph. Find an estimate of the gradient of the graph at time t equals 2.5 seconds, and you must show how you got the answer. So if there is a straight line already given, so we just have to use change in y over change in x, because the gradient of a straight line is always same. So if there's a curve given at particular point, if you want to calculate, if there is a curve given, the first thing is you should know that the gradient would be different at every point. Every point will give you a different answer. If they say that you have to calculate t equals 2.5, so x 2.5 here, I have to go straight up there. I'll find my point. So my point is here, and I have to draw a tangent. Why I'm drawing a tangent? Because the gradient of a straight line is always same. So the best is, if you want to calculate the gradient at the point, just draw a tangent and calculate the gradient of that straight line. So it would look like this. And now we have to calculate the gradient of this straight line using the formula, which is change in y over change in x. So gradient is change in y over change in x. We have to take 2 points, and then I have to do change in y over change in x. So first point, let me select this. I can pick this point, this one, that is, let's say this coordinate be 2.5 comma 20. Well, it's approximately 24, in between 20 and 21, so let's say it's 20. And the second one is, let me take this one here. This is 4 comma 3, that is 46. So 3 comma 4 comma 46. So change in y, that is 46 minus 20, over change in x, which is 4 minus 2.5, that will give you 26 over 1.5. On solving, we'll get, that will give you 17.3, and I'm taking as 17 as the answer. Why? Because that 20 wasn't like exact 20, so that's why. So let me take the 17 as the answer. And what does the gradient of the graph represent? Gradient of the graph represents a speed. See, if there's any other question where you have to find what will be the gradient of this graph, we know change in y over change in x is the gradient. So gradient is change in y over change in x. Here in this graph, change in y, that means on y-axis it's distance, so I'll write distance, and change in x, and on x it's time. So what it will give you? Distance over time is speed. Here in this, in place of distance, if it's written as displacement, then it would be velocity. If velocity is written here, then change in velocity over change in time will give you acceleration. So you just have to put the unit in the formula, and you can calculate what the gradient will give you. Moving on to the next question, question number 18. A solid frustum is made by removing a small cone from a large cone, as shown in the diagram. The slant height of the small cone is 6 centimeters. The slant height of the large cone is 10 centimeters. The radius of the base of the larger cone is 3 centimeters. Calculate the total surface area of the frustum. Frustum is this. First of all, you should understand what exactly the frustum is. A frustum is a figure when you can say dissect or remove the top part, the top small cone from a bigger cone. The remaining part is called frustum, which you can see this is original cone. And you have cut this one, the upper part, the upper cone, the smaller part. Obviously, if you take out this smaller part, this is a smaller cone. So the remaining part would be this one only. And that is called your frustum. There's one more thing. If you want to calculate it, one thing you should know that this smaller cone, this is smaller one, the smaller cone, and the bigger one, the original cone, this one, they both are similar. So the smaller cone and the bigger cone and bigger one, they both are similar. So that will give us an idea how can we easily calculate the surface area of the frustum. See, let me just draw it. This is a smaller part of the cone and this is the larger part of the cone. If I want to calculate the surface area of a frustum, I should know the area of this circle. Total surface area, that means sum of the areas of all the surfaces. I can clearly see three surfaces here. The circular one, this up there, the bottom circle, its area, and this curved one, this is the curved one. That is, obviously, you can see this part. That is the curved surface, and we have to calculate the area of all the three. Add them together will give me the total surface area. So first thing is, let me start with the circle, the smaller circle. Obviously, if I want to calculate the smaller circle, I should know the radius of the smaller circle. So radius of smaller circle is, let's say, r. Here. Obviously, this r is not given, but we have to calculate using one thing that I told you, that the smaller cone and the bigger cone are similar. And similar shapes are where the angles and the belt is exactly the same, only the ratios, only the corresponding sides are in ratio. So if you see this one, this is 6. Let me draw it here. This is 6 centimeters and this is 10 centimeters. So they are in ratio. So I would say 10 divided by 6. That is a scale factor and it will remain same. That means if this side is, say for example, 10 times of this, then this side will also be 10 times of it. This is also 10 times of it. Every time the ratio, the scale factor will remain exactly the same. So we got to know that scale factor here is 10 over 6 and this is also equals to, let's say this be r and this is 3. So 3 over r. This is how you can calculate the radius of this smaller part. So from here, r is equals to 6 times 3 over 10, which is 1.8 centimeters. So I get to know that the radius of the smaller part is 1.8 centimeters. So area of this smaller part is, let me write it down, area of smaller circle is pi r squared, which is pi times 1.8 whole squared. Then area of bigger circle. So area of bigger circle is this one and we already know the radius, which is 3. So it's going to be pi times 3 squared, which is 9 pi. Then finally the third surface, which is a curved one. So this, if I calculate the curved surface of this cone, and subtract the curved surface of this smaller cone, which is here. If I subtract it, so obviously this would be my remaining part. That is actually the curved part of the frustum. So to calculate the surface area, the curved surface area of a frustum, I can say the curved surface area or curved area, it would be better if I write area of the curved surface. So area of curved surface is equals to area of bigger cone, surface of bigger cone, curved surface of bigger cone minus area of curved surface of smaller cone. The formula is pi RL. So pi RL. So for bigger one, radius is 3 and length is given as L represents this length height, which is already given as 10, minus pi times radius is 1.8 that we have calculated, and length is 6 centimeters, which is given here. So it will be 6. That will give us the curved surface area of the frustum. So this is 30 pi minus 10.8 pi, and this will give you 19.2 pi. Now we need to add them all up. So here 1.8 times 1.8 will give you 3.24. So 3.24 pi plus 9 pi plus 19.2 pi. So in terms of, obviously they are not asking us to calculate in terms of pi, but let me find, it will give us 31.44 pi. Now put the value of pi and get the final answer. So on putting the value of pi, the final answer is 8.77 centimeters squared, or because they're asking you to give the answer to 3 significant figures, so it's going to be 98. Question 19 says Sana needs to draw the graph of y equals 3 to the power of x for x 0 to 4. She draws the graph shown on the grid. Write down one thing Sana has done wrong. See, obviously this is a curve, and if you see the numbers on y and x axis is also given, so we have to check the coordinates, whether she has plotted the coordinates correct or not, because it's from 0 to 4. So better is we see only these integers that are between 0 to 4. So 0, 1, 2, 3, 4, and I need to put these values of x one by one to get the y coordinates. So this is x coordinate, y is y equals 3 to the power of x. When I put x equals 0, it will give me 1. When I put x equals 1, it will give me 3. When I put x equals 2, it's 9. For 3, it's 27. And on putting x equals 4, it's 81. If I check it, I'll get to know that first coordinate they have drawn 0, 0, but it has to be 0, 1. For other, it's fine. 1, 3 is correct, I can see. For 2 till 9 is correct. 3, 27, 4, 81, it's perfectly fine. And also it's given, write down one thing Sana had done wrong. So obviously she has plotted 0, 1 wrong, whereas she has plotted 0, 0 wrong, and it should be 0, 1. So we can say that the correct coordinates are 0, 1, not 0, 0. So she has plotted 0, 0 wrong. Moving on to the next question. Prove algebraically that 0.123 recurring, that is 2, 3 is recurring, can be written as 61 over 495. And there's a simple method, because this is a recurring non-terminating numbers, it keeps on going and going endlessly. So here, to convert into fractions, we have to do some steps. We have to go through some steps. So first thing is, let's say x is equals to 0.123 recurring. Next is, now what I want to do is I need to multiply so that after decimal only there will be the recurring number. That's it. So if I multiply both the sides by 10, this will give me 1.23 recurring. That I wanted. I told you we have to multiply a number so that after the decimal there will be only recurring number. Previously 1 was there, which was not a recurring number. So that's why I multiplied by 10 so that I'll get the recurring number. I have to do one more time. One more time I have to multiply something so that there will be recurring number as well after the decimal. Because we know 1.23, 23, 23 endlessly. So if I multiply this with 1000, 1000, because 1 here, it was already, let me just show you. It was already 0.123 recurring. That means 232323. So if I multiply by 1000, 1, 2, 3, decimal will come here. So this will be 123.23, again recurring, right? So I told you have to multiply once again with a number so that there will be a recurring number after it. So that would be 1000. So I have to multiply x by 1000. So this will give me 1000x, and this is 123.23 recurring. And now I need to subtract it. This will give me minus 990x, and this will give me minus 122. That's it. Why? Because 0.23, why we were doing so that I will get only 0.23. I can entirely eliminate 0.3 after it. On subtracting, this will entirely get eliminated, and that's what we wanted. Now, dividing both the sides by negative 990, I'll get 122 over 990. And on simplifying it further, I'll get 61 over 495. And that they asked us to write it. See, it's a fraction. Whenever we add the fractions, any sort of, whether it's algebraic expression, fractions, or any other simple fractions, we always have to make the coefficients same. And here for algebraic, the best part is to multiply them together. That will give you the LCM, or the common multiple for denominator. So your common denominator would be x plus 4 times 2 minus 2x. How can I make, if I write 1 over x plus 4 plus 3 over 2 minus 2x equals 1. In order to make the same LCM, or in order to make this, I'll multiply the bottom one with 2 minus 2x. And similarly, here also, I'll do the same. If I want to make it same, I'll multiply x plus 4 here. And I'll multiply x plus 4 here as well. Now, once I have made the LCM same, which is 2 minus 2x times x plus 4, I can add these up. So up there it's 2 minus 2x plus, expand it, 3 times x is 3x, and 3 times 4 is 12, equals 1. So 2 plus 12 is 14, and minus 2x plus 3x is plus x. And then expand this one, so 2 times x will give me 2x, 2 times 4 will give me 8, minus 2x times x is minus 2x squared, and minus 2x times 4 is minus 8x, equals 1, which then can be simplified as 14 plus x over 2x minus 8x is minus 6x. So minus 2x squared plus 8 minus 6x equals 1. Then I'll cross multiply. So this whole will go there. So on cross multiplying, 14 plus x, up there it will be minus 2x squared plus 8 minus 6x. Now bringing all to the one side, so I'm bringing all left hand side, right hand side onto the left hand side. It will give me 14 plus x plus 2x squared minus 8 plus 6x. Obviously, when we transpose, sign always changes. So finally, it will give me 2x squared, 6x plus x is 7x, and 14 minus 8 will give me plus 6 equals 0. This is a quadratic equation that I have to solve, so it can easily be done by factorization method. I just have to find two numbers. Their sum should be 7 and the product should be equals to 6 times 2, which is 12. And two numbers are 4 and 3 easily. So by splitting the middle term, in place of 7x, I'll write 4x plus 3x, and that's why we have calculated or we have found those two numbers. So it would be 4x plus 3x plus 6. Let me make the pairs. So taking out 2x as common, remaining is x plus 2. And here take out 3 as common, remaining is x plus 2. So final factors are x plus 2 because they both are common, and the remaining is 2x plus 3. Because the product of two factors is 0, that means either of them has to be 0 or both can be 0. So that's why equating each to 0, I'll get x1 as negative 2, and 2x plus 3 equals 0, I'll get x2 as negative 3 over 2. And this is our final answer. It says, given that the vector a times 2, 6 plus b times 8, 2 is parallel to the vector 13, 6, find an expression for b in terms of a. So let me tell you, how can we find that two vectors are parallel if one vector is scalar multiplicative of another? Say if I say for example, vector AB and vector CD are parallel, then vector AB would be equals to k times vector CD. So one vector is a scalar multiplicative of another vector. So same thing, I can say, let me simplify this vector first. So this is going to be a times 2, 6 plus b times 8, 2. On simplifying, I'll get, because whatever be the constant outside, we have to multiply it. This is called scalar multiplication. So this will become 2a and 6a plus this will be 8b and 2b. When you add it up, it will give you 2a plus 8b and 6a plus 2b. This is equals to scalar multiplicative, which is k times 13, 6. So my equations will be 2a plus 8b is equals to 13k, and second equation would be 6a plus 2b equals k times 6. 6k. Because we need to find an expression of b in terms of a, that means we have to eliminate k. So what I can do from here, I can say k is equals to 2a dividing both the sides by 13, 2a by 13 plus 8b by 13. And put this value of k here, right here. So it will be 6a plus 2b equals, what we do in simultaneous equations, we always, like elimination method is different. In substitution method, we find the value of one variable from equation 1 or from one equation and substitute it in another equation. So this will be 6a plus 2b and 6 times the value of k, which is 2a over 13 plus 8b over 13. 6a plus 2b is equals to 12a over 13 plus 48b over 13. Finally, separating out a's on one side and b's on another side, this would be 6a minus 12a over 13 is equals to 48b over 13 minus 2b. Then this can be simplified as taking LCM. I'll get 13 times 6 minus 12a, and here 48b minus 26b over 13. So this will give you 78 minus 78a minus 12a over 13 is equals to 14b minus 26b over 13. That will give you 66a over 13 equals 22b over 13. Cancelling out 13 and 13, 22 times 3. So b is equals to 3a. That's your final answer. Moving on to the question number 23. A circle has equation x squared plus y squared equals 25. So this is the equation of a circle whose center is 0, 0 and whose radius is 5, because the standard equation is x squared plus y squared is equals to a squared. So on comparing, I'll get a, that is radius, as 5. So it would be this. That is 5, and our center is 0, 0, and the equation of this circle is x squared plus y squared equals 25. The point P with coordinates -3, 4 lies on the circle. Alex says the tangent to the circle at P crosses the x-axis at point -8, 0. Is Alex correct? So let me show you by drawing it properly. So obviously if the center is 0, 0, that means this is origin and circle is like this. It's at the center of the intersection of both the axes, x and y. Now -3, 4. So -3 would be here, 4 is up there. So I would say somewhere here, let me say it would be here. So -3, 4 is a point here. And the tangent to this point, so I'm just drawing a tangent to this point, this one. So tangent to this point, it says when it passes to x-axis, it will pass through -8, 0. This coordinate has to be -8, 0. So we have to prove whether Alex is correct or not. Obviously, if I want to know that whether this line, whenever this straight line passing through x-axis, it will pass through -8, 0. For that, I should have the equation of straight line, this tangent, equation of this tangent. So how can I find the equation of the tangent? First, we know that this is a tangent at point P. And if I join it, this is a radius. There is a circle theorem which says that the angle between the radius and the tangent is always 90 degrees. So that's why I have connected to know that this is 90 degrees. Now these both are straight line. This radius and this tangent, this both are straight lines. And we know that if two lines are perpendicular to each other, there is a condition that the gradient of one straight line is reciprocal, negative reciprocal of another gradient. So gradient of radius is y2 minus y1, that is 4 minus 0 over x2 minus x1, which is -3, 0, that is -4 over 3. That's the gradient of radius. As I told you, if two lines are perpendicular to each other, one gradient, the gradient of one line is always the negative reciprocal of another line. So if this is the -4 over 3, then the gradient of tangent would be negative reciprocal of this one. So gradient of tangent is negative reciprocal, that is 3 over 4. That's the gradient of the tangent. Now we have to find the equation of this. We know that y is equals to mx plus c is the standard equation. Gradient we have calculated, which is 3 over 4. So y is equals to 3 over 4x plus c. Now we have to plug in the values of any one coordinate that is on the straight line, which is surely and clearly negative 3 comma 4. So I can plug in the value of x as negative 3 and y as 4. So here in place of y I'll write 4 and in place of x I'll write negative 3. So this is 4 equals negative 9 over 4 plus c. Moving on to this one, this will give you 25 over 4 equals c. I have just added the fraction 4 plus 9 over 4. Taking LCM, it would be 16 plus 9 over 4. That will give you 25 over 4. That's the value of c. Now we have our equation of a straight line, which we have calculated as y equals 3 over 4x plus 25 over 4. I want to know this will pass at this point. So when this straight line will pass through the x-axis, y will be 0, obviously. So I need to plug in the value of y as 0. So when I plug in the value of y as 0, 3 over 4x, because just like I have plugged in the value of negative 3 comma 4, because these are the 2 points that are there on the straight line. Similarly 0 comma, let's say a. Okay, let's say a comma 0 lies on this one. So I'll plug in the value of x as a and y as 0. So on plugging, it will give me this. I'm writing rest of here. So this will be negative 3 over 4a is equals to 25 over 4. Cancelling out, a is equals to negative 25 over 3. That means this point is actually negative 25 over 3 comma 0. And that's not negative 8 comma 0. So Alex is incorrect. Question says there is a total of y counters in a bag. There are x pink counters, 5 blue counters in the box, and the rest of the counters are green. The ratio of x to y is 1 over 3. Frida takes at random 2 counters from the box. Find in terms of x an expression for the probability that the Frida takes 2 counters of the same color. Give your answer as a fraction in the form of ax squared plus bx plus c over dx squared plus ex, where a, b, c, d, e are integers. So we know that in a box there are y counters in total, and out of them x are pink, 5 are blue, and rest of them that means definitely y minus x plus 5. Why? Because let's say green be g. So x plus 5 plus g is equals to y. So from here I'll get to know that g is y minus x minus 5. That is, number of green counters are y minus x plus 5. Okay, see. Because your final answer has to be in terms of x only, so that's why we have to use this one. The ratio of x to y is 1 over 3. So ratio of x over y is 1 over 3. From here, I can write that y is equals to 3x. I just need to replace y with 3x. So 3x minus 5, which is 2x minus 5. This is green. Now, it says that Frida takes random 2 counters from the box. And find in terms of x an expression for the probability that the Frida takes 2 counters of the same color. So possibilities are she will pick blue, or, and whenever there is or in probability or combination, we always add them up because these are separate possibilities. Probability of green plus probability of pink. There are 5 blues out of y that she will select. Okay, because y is 3x, so I'll write 3x directly there. So I can say 5 over 3x times, if she has already selected one counter, then for the next chance, for the next pick, she's already lacking one counter. So now the 4 counters are available out of 3x minus 1. Plus greens are 2x minus 5. 2x minus 5 out of 3x times, there will be 1 less now, the green counters, so 2x minus 6 over 3x minus 1. Plus pink, so there are x pinks out of 3x times x minus 1 out of 3x minus 1. I can clearly see that every term has the same denominator, so we need not to worry on making them same. So I can write 20 over, well, we have enough space, so I can use this one as well. 20 over 3x times x minus 1 plus 2x minus 5 times 2x minus 6 over 3x times 3x minus 1 plus x times x minus 1 over 3x times 3x minus 1. So this will be 20 plus, I'm just making all the denominators same. 2x times 2x is 4x squared. 2x times minus 6 is minus 12x. Minus 5 times 2x is minus 10x. Minus 5 times minus 6 is plus 30. Now x times x is x squared. And x times minus 1 is minus x. Let me simplify. So 4x squared plus x squared is 5x squared. Then minus 12x minus 10x and minus x is minus 23x. And 30 plus 20 is 50. Over 3 times x is 3x squared. Minus 3 times 3x minus 1 is 3x. And this is your final answer. Sorry, this is 3, I just missed out. This is 3, so that will make it 9x squared. Okay, so that's it for today. We have completed this whole paper, and in the next class, we'll be meeting with the next paper. So I'll be again saying that I have already started the crash course batches from 1st of January, and we haven't done too much if you really need it. And also we are looking for starting some more batches from February as well. Also the paper solving classes as well. So if you are looking for any of these classes for GCSE A levels and even for 11 plus, just drop us an email at exactacademy@gmail.com. And also if you're looking for any classes from year 1 to year 13, just drop us, and for any subject, we have tutors for all subjects basically. So just drop us an email at exactacademy@gmail.com. So that's it for today. Thank you. Have a great day.